Hey guys, it's me again. I'm back to go ahead and teach you how to go ahead and solve a nice problem. This one right here is a nice example of a real-world problem involving exponentials. The question is this. Reproductions in in a bale of sea turtles can be modeled with the equation n equals 100 times e to the power of 0.003x, where n is the population of sea turtles and x is the number of years since the original 100 were introduced to the to the area. Find the number of years it takes for the population to double. And B, can you determine how many new turtles were born for a given year? Find how many sea turtles were born during the 12th year. Now, this problem might seem initially difficult, but it's actually a very simple problem. This first one is asking us for how many years it takes for it to double. So notice that here it tells us that originally there were 100 introduced to the area. So if our start was 100, then we must end when we have 200. So that means that our problem, then n is going to be 200 because that's how many we end with. And everything else, we just simply input the equation. 100 e to the power of 0.03x. And now we just have to find out how to solve this. Now, here the main problem just comes down to how do we go ahead and get x by itself. And you'll notice that we have both this exponential, which is this e portion here, and we also happen to have this constant multiplier. We're going to get rid of the constant multiplier first, since that part is the easier one to get rid of. Generally, when you're trying to solve an equation, you want to go in reverse order. And remember that we would do multiplication after the exponent, so multiplication is what we get rid of first, since it's what we would have done last. So dividing 100 on both sides, we have 2 equals e to the power of 0.03x. Now at this point we need to go ahead and get rid of this e. Now that means, this right here is an exponential with base e, and so we need to do the opposite. And what is the opposite of e? That'd be the natural log. So we're going to go ahead and solve this with a simple natural log of 2 on both sides. Natural log on both sides. The first one is going to be a natural log of 2. And the second part is going to be, once again, e to the power of 0.03x. The natural log and the e cancel out, leaving us with the natural log of 2 equals 0.03x. From finishing solving, this tells us that x must equal 0.03. One second, made one error. Let's fix that quickly. It'll equal the natural log of 2 divided by 0.03. And this gives me my final answer. Now, in order to go ahead and get the decimal approximation, if I wanted that, I would simply pull up my calculator as such, and I would type this in exactly as it appears. So natural log of 2 divided by 0.03. Press enter, and there it is. This will take me approximately 23 years for the population of turtles to double. So this is approximately 23 years. Now this next part asks how many turtles were born in a given year. Now this equation might seem difficult at first, but the reality is if we know how many turtles from this equation exist in one particular year, to find out how many turtles were born in that year, we just need to subtract how many turtles already existed the previous year. So effectively what we're looking for is 100 e to the 0.03 x minus 100 e to the power of 0.03 times x minus 1. So we're subtracting 1 on both sides with the intention of asking for the previous year. After all, if x were, in this case, 12, then x minus 1 would be 11. So we're taking the number of turtles in the 12th year and subtracting how many were in the 11th year, and this will give us how many turtles were born. So to actually find how many turtles were born in that year, we simply replace x with the number 12, which would give us the equation 100 e to the power of 0.03 times 12 minus 100 e to the power of 0.03 times 11. Once again, to solve this problem, we simply pop open our handy dandy calculator, go ahead and type in 100 times e, which we normally get to by finding the inverse of natural log, so second natural log, and we put in 12 here. And we're going to go ahead and subtract from this 100 e to the power of 11. Our answer ends up being, sorry, I made one error. Let me just go ahead and correct that error. The error I made, and as I said, making an error is always a fine thing. Everyone does it, including your teacher. Is simple. The original problem, as written here, says 0.03x. I forgot the 0.03. That was the only issue. So 0.03 times 12. And over here, it'd be 0.03 times 11. Then when I press enter, there we go. 4 turtles is the correct answer, or about 4 turtles. Usually these equations are hardly ever going to be exact. So all problems of this sort, just to go through the basic logic, will usually involve in some way either using an inverse in order to solve for x, if our goal is to solve for x, or it's going to instead just simply use the original equation, but it's asking something like, what will the x's be in these cases? And that's really it. That's all you're doing anytime you're trying to solve a problem like this. So that ends this video for today, and I hope this video finds you well. Hope you guys stay safe and have a wonderful day.